Now there's the shifting function to talk about. So I'm going to kind of box this off. I don't have room to continue the partial fraction expansion here anyway, so I'm going to use this space to talk about the Laplace transform of e to the alpha t f of t. That's going to be what? It's going to be the integral from 0 to infinity of e to the alpha t, e to the negative st, f of t, dt. Okay, well that's just the integral from 0 to infinity of e to the what? Negative the quantity s minus alpha times t f of t dt. Because, of course, e to the alpha t times e to the negative st is e to the alpha t minus s of t. You factor out the t, you get e to the alpha minus s times t. And put a negative in front of it for reasons you'll see in a second. Well, the reason is simple. Okay, I've got this, and I've still got my f of t dt. And okay, I've replaced my s with an s minus alpha. Okay, so this is, I don't have room to write it out in detail, but I've replaced s by s minus alpha, and what this is going to be then is f of s minus alpha, where f is the Laplace transform of f of t. Okay. Now I could write out an extra variable, replace s minus alpha with sigma. And I'd have e to the negative sigma t f of t dt. There'd be a little bit of a transition because s equals 0 corresponds to sigma equals a, and that's where the shift comes in. But the bottom line is that the integral, well, e to the alpha t f of t is equal to the Laplace transform of f of t, where s is replaced by s minus alpha. Okay, so that the inverse transform of this, let's take this, okay, the s that you get for the cosine function, for this function, has been replaced by s plus 1. Okay, so s minus alpha is s plus 1, so alpha is negative 1, so you have an e to the negative t here. Okay, well, I'm going to write that out in a little more detail. I'll write this rule out in a little more detail, but I wanted to give you at least some explanation of where that rule comes from. And just this, and when you look at this, if you understand what you're seeing, you see this. Okay, well, we'll continue.